Today, let's discuss a book published in May 2022, titled Evolutionary Ideas. Unlocking Ancient Innovation to Solve Tomorrow's Challenges, authored by Sam Tatam. Tatam is an organizational behaviorist and the global head of behavioral science at Ogilvy, a UK-based consulting company. I consider this an underrated gem. It was published over a year ago and doesn't have a Chinese version yet, but it's packed with valuable insights. The book explores the application of behavioral science, specifically using various tactics from evolutionary psychology to address business challenges, such as influencing consumer behavior through advertising. Tatam notes that, the progress of psychology in the past 30 years has surpassed that of physics and economics. Our understanding of the human brain in these 3 decades exceeds that of the past 3,000 years. While I've previously written about evolutionary psychology, reading this book made me realize that it has evolved beyond being just a discipline. It's now an engineering tool that can be applied in various designs. The title, Evolutionary Ideas, refers to well-evolved concepts, strategies for manipulating human behavior. Tatam's intention in writing this book is ambitious. Before delving into evolutionary psychology, let's ponder a broader question. Can innovation be learned? In other words, is there a method to innovation? Are there limited or unlimited approaches to innovation? Commonly, people perceive innovation as a flash of inspiration or a gift from the heavens. Especially considering Stephen Wolfram's computational irreducibility, we know theoretically there are an infinite number of creative ideas. Even if you compile all the good ideas you can find into an Inventor's Handbook, someone will inevitably propose an idea not in your manual. However, if we disregard groundbreaking inventions like computers and focus on everyday innovation, such as product design, the existing good ideas are often sufficient. With keen observation, bringing in a new product is often a recombination of existing ideas. Steve Jobs famously said, "Creativity is just connecting things." When you ask creative people how they did something, they feel a little guilty because they didn't really do it, they just saw something. They were able to connect experiences they've had and synthesize new things. So, the saying goes, synthesis is creation, and we often say, creation is connecting ideas. Now, I want to ask, if someone lists all good ideas for you, could you invent and create by simply following the instructions and combining a few? Yes. And people have been doing it for a long time. Let me tell you a story. There was a brilliant inventor in the Soviet Union named Genrich Altshuller, 1926 to 1998. Even during elementary school, he obtained a patent for an underwater diving apparatus. In high school, he invented a rocket boat using carbides as fuel. In his 20s, Altshuller joined the Navy and quickly invented a method for submariners to escape without diving equipment, a technique adopted by the Soviet military and classified as top secret. Therefore, the lack of Soviet innovation wasn't because Soviets lacked capable individuals. Altshuller himself was adept at inventing, but he noticed his colleagues weren't as skilled. He thought, what's so difficult about it? Let me teach you. Altschuller's confidence stemmed from his experience working in the patent office of the Navy, where he reviewed numerous patents. He found that while a few inventions originated from entirely new ideas, the majority reused the same solutions, merely transferring them from one field to another. Altshuller conceived a grand plan. Compile all the patterns of innovation into a unified system. This system is called TRIZ, derived from Russian.
Теория решения изобретательских задач.
Meaning. Theory of inventive problem solving. Altshuller, full of confidence, claimed that with this system, he could teach engineers how to invent. He even wrote a letter to Stalin, complaining about the low and chaotic efficiency of naval research and suggesting the widespread adoption of his method. This complaint irritated the higher-ups in the Navy, especially during Stalin's era of constant political purges. Altshuller ended up on a blacklist. In 1949, he was arrested, subjected to continuous torture and interrogation, and sentenced to 25 years in prison. Fortunately, Stalin died in 1953, and Altshuller was released in 1954. Since then, TRIZ gained popularity in the Soviet Union. TRIZ summarizes all inventive ideas into 40 principles, ready for direct application. For example, the 11th principle is beforehand cushioning, suggesting that, to address potential problems, you should leave room for buffering in advance. For designing an airplane, prepare life jackets under passenger seats and reserve additional oxygen overhead. For designing a parachute, have a spare one to prevent malfunctions. For designing a Formula 1 racetrack, place tires along the edges to prevent cars from going off track and getting damaged. Mastering these principles provides various perspectives when inventing something new, preventing you from fumbling in the dark. The overall logic of the TRIZ method can be summarized in 3 points. 1. The same problems and solutions repeatedly appear in different industries and disciplines. 2. Patterns of technological evolution repeatedly emerge in different industries and disciplines. 3. Innovative methods in one field can be applied to others. Even more impressive is the contradiction matrix within TRIZ. Many inventions involve balancing various contradictions. For example, bulletproof vests need to be sturdy but not too heavy, or parachutes need to unfold large but fold compactly. How can you satisfy these conflicting requirements? By inputting these needs into TRIZ matrix, it can identify intersections, providing several principles as potential solutions. This goes beyond mere inspirational methods. It's a handbook you can directly use. A guidebook, a manual. Technological invention no longer requires random brainstorming. Soviet secrecy was effective, and it wasn't until after the end of the Cold War that TRIZ was introduced to other countries by former Soviet immigrants. In 1995, a TRIZ research institute was established in Boston, USA. Even today, you can find many new books introducing the TRIZ theory. Sometimes, it's referred to as the innovation algorithm. The lesson here is that there are already many existing good ideas worldwide, perhaps in a neighboring field. Just bring them over and use them. Of course, TRIZ primarily deals with engineering design, and can't encompass good ideas in all fields. For areas farther from engineering design, such as psychology, there should be a TRIZ system tailored for those fields. Listing and utilizing good ideas is feasible and applicable across disciplines. Nature has always worked this way. An interesting phenomenon called convergent evolution occurs, meaning different species independently discover the same solutions during their separate evolutionary processes. For instance, birds, bats, and many insects all use wings to solve the problem of flying. Is this a result of genetics? No. These 3 species didn't have wings in their distant common ancestors. They independently invented wings. So, it seems that there aren't 100 different solutions to make something fly. Wings are the optimal solution, to the extent that all tried and tested it. Similarly, cacti, as plants covered in spines, have a defense mechanism, and porcupines, as animals, also use spines for defense. Are they imitating each other? No. Long spines are a universal solution, and they independently discovered it. Another example is dolphins, mammals that breathe through lungs, and sharks, fish that breathe through gills. Their evolutionary relationship is as distant as horses and seahorses. Still, dolphins and sharks share a high degree of similarity. Streamlined bodies, dorsal fins, and pectoral fins for fast movement. The most famous example is eyes. Human eyes and octopus eyes are highly similar, and their common distant ancestors didn't have eyes. The solution of eyes evolved independently in each lineage. The variety of life is vast, but convergent evolution illustrates that solutions in the biological world are quite limited, with only a few popular ones. This parallels the field of technological invention, where major new inventions are often made simultaneously by several inventors. Given this, why not list all the good ideas from the biological world, creating a system for easy comprehensive use? This is the roadmap of biomimicry. Tatam shares an intriguing example. In the late 1980s, Japan faced a significant issue in developing the Shinkansen bullet train. Noise. When the train ran at high speeds, the pantograph on the roof would cut through the air, generating loud noise. Additionally, when entering tunnels, compressed air created sonic booms, resulting in excessive noise. How do you deal with the noise when your high-speed train becomes a nuisance? In 1990, Japanese engineers decided to learn from bird experts. They discovered solutions from 3 bird species. Firstly, the owl. When owls fly, they make almost no noise because their feathers have small serrations that create tiny turbulence in the air, significantly reducing noise. So, Japanese engineers incorporated many tiny serrations into the pantograph, effectively reducing noise. Next, the Adelie penguin from Antarctica, known for its high-speed swimming. Why? Because its body is spindle-shaped. Inspired by this, engineers shaped the pantograph like a spindle, reducing air resistance and further minimizing noise. How about reducing noise when entering tunnels? Engineers borrowed from the kingfisher's beak. The kingfisher can dive into the water at high speeds without splashing because of its long, pointed beak, gradually widening in a streamlined shape. This inspired the design of the bullet-nosed train front. In 1997, Japan introduced the Shinkansen with a speed of 300 km per hour. These insights borrowed from bird knowledge not only significantly reduced noise but also saved 15% of electricity. When China later adopted Japanese technology for its high-speed rail, they didn't need to learn directly from birds anymore. The essence here is that after billions of years of evolution, every living species on Earth is a success story. They possess things worth learning, presenting fantastic solutions. This underscores the significant importance of preserving biodiversity. We never know what we might learn from which species in the future. The theme of Tatam's book is that within the human brain, too, there are various well-evolved ideas due to evolution. Let's explore this further in the next part.
If you feel there is value in this, please like, subscribe to this channel, and leave your thoughts or suggestions in the comments section. Let's grow together and read more good books.